Hi, I'm Valérie Allier from Interdigital. I'm happy to present the MPEG V-PCC and immersive video use cases and real-time implementation demonstrations. With new immersive codec, you will increase user engagement in all entertainment experiences, from live event to XR experiences. As the next generation of content, volumetric video creates new immersive experiences. With volumetric video, you enable increased immersion into content. You allow users to experience the sensation of depth and parallax. Let's explore how volumetric video content creates a sensation of depth and parallax. On the left, you see a volumetric scene where you can feel the depth and parallax. On the right, you have a volumetric character, which has been shot with a volumetric setup. Here we can see how this volumetric content can be used. For instance, on the left, in fact it is a video pause and a dynamic point of view rendering while the user is moving in front of a TV set, for instance. On the right, the single character has been integrated in an AR experience, and here the volumetric feature is really mandatory. Users can experience volumetric video in a variety of ways, targeting different use cases with different types of devices. Here, for instance, in a VR use case, where the user is wearing an head-mounted display, he will be able to get more immersed with a less discomfort with volumetric video with parallax. Here you can see a CG-based volumetric video. Here, you have a real volumetric video capture with a volumetric setup. Here, on a smartphone, the user with a simple touch-based interface can be more immersed with virtual viewpoints of a volumetric content. Volumetric video targets also future displays with multi-view displays coming on the market. Here, for instance, this is the looking glass display with different views, allowing multi-user experience of volumetric video. Targeting an AR experience with a mobile device or a headset, using volumetric video will help to have a seamless integration between the real world and the added elements. Let's present now some V-PCC streaming and rendering implementations. As seen previously, we have an Android phone implementation where the model integration is done in AR space using AR Core, with a touch interface targeting a 30 frames per second. We also have an NVIDIA Shield and Windows implementation where the model is integrated in VR space using high-res 3D scans, targeting also 30 frames per second. Let's view here some V-PCC-based models integrated in a 3D scene. And we also have an Unreal implementation with the model integration in MR space using Unreal SDK, and with an optimization to also reach the 30 frames per second. Here again, we see the V-PCC characters integrated in an AR environment. Let's move now to the MPEG immersive video streaming and rendering implementations. Here we have the VR implementation with the rendering of 2 views for the HMD and a real-time rendering at 200 FPS. We have an Android implementation for the tablet, also targeting 25 FPS. And we have the Looking Glass implementation with 45 multi-view for each frame, targeting also the 25 FPS. Obrigado. Thank you for watching this video. For a deep dive in V-PCC and MIV codec, please watch our joint Interdigital and Philips video in Set Experience website.